Kara Sridhar. I guess my first question is a lot of people have tried solid oxide fuel cells for years, and it's been a holy grail in the industrial world. If you could tell us, what are some of the technology or what are some of the ideas you've incorporated in your boxes to actually come out first?
Well, the technologies that we have adopted are the ability for our electrodes to handle multiple fuels without need for any switch. Number two, the ability for our electrodes to take that fuel without the need for an external reformer to produce hydrogen out of it, the big chemical reactor that you have outside. The third thing is the ability to make metal plates that have the same thermal expansion as our metal throughout the temperature range, so our ceramics are not stressed as you heat up and cool down.
Okay.
And what we need to do. The ability for us to take all the heat that's being generated in the system and put it to good use to develop just electricity and no heat. As you see in our boxes, put your hand around it, put your hand around the exhaust. It's cooler than a car exhaust. So we don't put any heat out, and we use all that heat to produce the most amount of electricity. These are all innovations. These are all very different from what other people have done. And also in the solid oxide feed, nobody has taken a planar fuel cell, solid oxide fuel cell, and tried to build it at the scale that we have built it.
Yeah, the very modular, where you can take the plates out and stack them. And
they do 1 kilowatt, half a kilowatt for a small home. It is mainly a furnace that also gives you some electricity. We don't believe in that model.
Now, how did you switch? Because a lot of people have fuel cells, but they do more of a lower temperature, and they do more of a cogen model. They have a lot of heat, some electricity, but the electricity you're getting out is actually much higher.
Yeah, so chemistry simply says the higher temperature you go, the higher the efficiency is going to be. That's just fundamental thermodynamics. So why do people go to lower temperature? For two reasons. One, they don't know how to handle the high temperature, and two, they don't know how to handle the material challenges associated with the high temperature. We have figured out the material science and the thermal packaging to be able to handle the high temperature. And once you do that, you have a wide variety of fuels that you can use, as opposed to them that cannot use a wide variety of fuels. So what we decided from day one in the company, we wanted to solve only the difficult problems. We didn't want to find the easy answer. We didn't want to find the first little thing that could work. We knew what we were after. We were after the Holy Grail. And if we didn't get that, we didn't care.
Interesting.
That's the only thing we wanted, and we went after it.
Now, I wonder if you could walk through the process first. Let's say you have methane or a biogas comes into the system.
Yeah.
It's mixed with oxygen right away, or is it passed through a membrane?
It mixes with water, which is a byproduct of our exhaust.
Right.
And the water and methane goes into the system. And within the system, the methane and the water react, and you get what is called a syngas right on the surface of our fuel cell. And oxygen comes from the air side of the fuel cell and mixes with the CO in the syngas to form carbon dioxide. And oxygen comes across the membrane again from the air side, mixes with the H2 in the syngas to form water. And both those reactions are accompanied by electrons flowing on the outside. And that's the basic reaction. We eliminated the reformer, we eliminated the chemical reactor, because we operate at high temperature, we eliminated the need for expensive noble metals, and we eliminated...
Which everyone else has to worry about.
Which everyone has to worry about. And we eliminated the need for figuring out where to take all the heat and what to do with it. The heat is an asset in some places, it's a liability in other places. The customer simply wants a plug-and-play electric device, and that's what we gave them.
Now, what were the? We talked today that it's 9 to 10 cents a kilowatt hour, and that includes everything. That includes maintenance, installation, gas,
all put together.
What was it? Let's say even 2-3 years ago, and what do you think the price might be 2-3 years ago from today?
From the very first time we built something to where we are today, we have dropped the price 25% in terms of what it costs. 25 times, so 250. Okay, 2,500%. We know where we need to go. You guys know what the subsidy is. We will get there. Yeah. We are confident that the subsidy is a feeding bottle and not something that we need forever.
Who are the main customers? Do you think utilities might be the main proponents or sales channels for this? I mean, it's a lot easier building a power plant.
You know, it's logical, right? Utilities are in the business of selling electrons to their customer, servicing them, and collecting a fee. And
they don't care what makes it, as long as they can.
They don't care who makes it, and we are giving them some benefits. What are the benefits we're giving them? They don't have to extend the transmission distribution line, which is almost being run to fail in so many places, by putting this right near the customer side. So we are actually helping them from a deferred cost of transmission distribution. By not running their transmission distribution lines at peak, they offer greater stability to everybody, right?
That's true, yeah.
That's a second benefit we are offering them. The third benefit we are offering them is by running on biogas. These can be their RPS devices, and they meet the RPS standard that most states need. The fourth thing is, most renewable assets that they buy and put are intermittent, and it causes a problem for them in terms of grid stability. We offer them 24/7. So there's just absolutely no reason for the grid not to want this and do it.
Now, who do you think?
Sorry, the utility not to want this and do this.
Now, who do you think might come after you to compete? Do you see like GE and Siemens?
You know, we welcome competition. This is a big table. This is a very big market. Competition is good for any industry. There's plenty of room at the table for everybody. This is bigger than the automotive market, and there are big automotive players who are all profitable.
But it's very utilitarian.
I just want to be number one.
Okay.
Okay, that's all I care about.
Well, how do you think you'll compete against solar and wind? Do you think you, even now, can offer a better value proposition than you will in the future?
That's not a competition. We are a 24/7 base load, and solar and wind are not. So they're not competing. We are a completely different category from them.
What is power? I mean, you'll have a big company will look at power and say,
you know, whether it's your home or your business or your shop or office, you need to make hay when the sun doesn't shine. And you don't have that. You don't have a reliable power source.
And one last thing, in the future, you've talked about actually building in some pipes and some equipment to take the water, add some electricity from solar panels, and then produce hydrogen again.
Yeah.
How does that work, and when do you think that'll roll out?
We have, like I said, we have proven the entire technology out, but our market analysis shows that given the cost of solar, given its efficiency, given our costs, right now if we build that product, people will not buy it. Unlike if we build this product, we can't keep it on the shelves. So we focus on this first. It's our estimate that the market will be ready for a product like that 8 to 10 years from now. And we definitely have the technology and the ability to put that product right when the market timing is right.
I heard you had a backlog of $1 billion in orders.
No comment on that.
Okay, great. Well, thank you very much.
No.